What up, what up? You're about to take AP Precalculus. You're scared. And you know what? You should be. But I'm going to make sure that throughout all of these videos that I provide for you, you're going to go into pre-calc feeling a little bit more prepared, a little bit more confident, so you don't end up contemplating your life choices after a week or two of school. And maybe along the way, we can have a laugh or two. But you'll probably mostly be crying. I think I have 5 parts to this. Part 1 here is solving and graphing linear equations. There's a lot of solving going on, a lot of graphing too, and we're going to just start off a little simple by focusing on the linear side of things. So, right off the bat, we have ourselves a distributed property 2-step style equation. So let's get right to it. First thing you want to do is distributed property. So multiply 3 to both things right there. 75 doesn't change. So let's just drop it down. 3 times -6 is -18. N comes along for the ride. 3 times -5 is -15. There's that 2-step that I was talking about earlier. Now, when you have a 2-step, you always want to try to get rid of the constant first. Do that using the inverse, which is add 15, cross u out, and 75 plus 15 is 90. Drop down the -18n, that hasn't changed. Last step, if -18 is being multiplied to n, divide both sides by -18. And 90 divided by -18 is -5. Now, depending on how picky of a teacher you have, they might be okay with this. If you're going to go into pre-calc, you've obviously have been through Algebra 2, and we're going to deal with inequalities and AP Precalculus. So I prefer flipping things and saying n equals -5. But then again, it's up to your teacher, and it's not a necessary step. But that's solving a 2-step equation with distributed property. So not so bad at all, as Eminem once reminded us. Now we have distributed property again, but it looks like there's variables on both sides of the equal sign. Let's distribute first. Whenever you have distributed property, that's 99% of the time the first thing you're going to want to do. So 6 times 6v is 36v. 6 times +6 is +36, and everything else just kind of falls into place. -5 equals 1 plus 6v. Let us combine like terms. So you become 31, my age in a few years. That's the laughs part I was talking about earlier. That's going to equal 1 plus 6v. We have variables on both sides of the equal sign. I always like getting rid of the guy on the right, so I'm going to do that. Let's subtract 6v because that's a +6v. So subtract 6v, cross u out. 36v minus 6v is 30v plus 31 equals 1. Now it's a 2-step. Minus 31 minus 31. 1 minus 31 is -30. So 30v on the left side drops down. And I'll divide both sides by 30 because 30 is being multiplied to v. Negative divided by positive is negative. And a number divided by itself is -1 in this case. Usually it's just 1, but in this case it's -1. So v is -1. If you had all the time in the world, you can plug -1 back in, plug -1 back in, and whatever math you do on the left side should exactly be the same exact type of thing you see on the right side, and you would get something like 12 equals 12 or whatever it may be. Okay, so that's solving the equation, variables on both sides of the equal sign, distributed property, bada bing. Distributed property again. I see a lot of similar things here. All right, anyway, 12 times 2k is 24k. I'm assuming that since you're taking AP Precalculus, none of you understood that reference. It's a video game. 134, no, 132 is going to equal 12 times 2k. Interesting. 24k again. Interesting. 12 times 12 is 144. Now, it's interesting because on the left side you have 24k, and on the right side you have 24k, which means if you subtract 24k from both sides, all of the variables disappear. And what you bring down is 132 equals 144. Now, is 132 equal to 144? No. So what's my solution? There is no solution. So when the variables disappear, or if you notice that the left side, the variable is the exact same thing on the right side, those variables go away, and you're left with no more variables. If the numbers aren't the same, it's a no solution. Conversely, if you have the same amount of variables on the left that you have on the right, you have a 10x on the left and a 10x on the right, they disappear, and you end up with 50 equals 50. What does that mean? That's the infinitely many solutions. Okay, this is the no solution because the variables went away and the numbers don't match up. When the variables go away and the numbers are exactly the same, infinite solutions. I don't think I have one of those on here. I didn't want to double dip. So that's that. Clearly, they're getting more challenging as we go on. That's kind of the point. It's AP Precalc. Don't expect baby problems. It is, if you're watching this in 2023, and it's the first time ever that anyone's taking AP Precalc, all teachers know, like me, I teach AP Precalc now. All I know are the few practice tests that we have online. And whatever information College Board is willing to give us. So we're just making sure we cover everything. On the left side, we can combine like terms. 10p take away 1p is 9p. Okay, 9 minus 11, never forget, is negative 2. On the right side, I have two distributive properties. Negative 2 times 2p is negative 4p. Negative 2 times positive 4 is negative 8. Distributive property again. This is not 3. This is negative 3 times 2p, which is minus 6p. And again, this is negative 3 times negative 2, which is positive 6. Now, the right side, what's going to happen is the same thing that happened originally on the left side, where we can combine like terms. Right now, nothing changes on the left side. On the right side, we should be able to combine negative 4p and negative 6p to make negative 10p. And then we have negative 8 and positive 6, which is negative 2. So I take away my and you'll see what I mean in a second. Negative 10p on the left, 9p on the left. I'm sorry, negative 10p on the right, 9p on the left. I like moving my variables to the left side, so let's do that. Let's do the inverse of negative 10p and add 10p to both sides, giving us 19p. Now, originally I went because I knew that I would have to divide by 19 at some point. But now looking at what I have, kind of piggybacks off the last problem that we just did. On the left, I have negative 2. On the right, I have negative 2. What does that mean? The negative 2's will just go away. Once I add 2 to both sides, I have 0, and that makes my problem a whole lot easier. So 19p equals 0. And my last step is divide both sides by 19, and 0 divided by anything, as long as it's not 0, is 0. So p is 0. After all of that. Okay, and again, like I said with the problem a couple problems ago, if I wanted to double check my work, which in this case wouldn't be so bad because it's 0, I could just like plug 0 in, plug 0 in, plug 0 in, plug 0 in. I'll eventually get something to the effect of negative 2 equals negative 2, which means I did it correctly. Look at us having a good time, huh? Now let's do some graphing. Full disclosure, I am terrible at graphing on this little thing in the writing pad that I use. So if it's not a straight line, Don't run to the comments and be like, this guy with his 12 followers, blah, 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 blah. I don't need that. I don't need it. Whenever I'm graphing something where y is all by itself, I immediately go to slope-intercept form. Slope-intercept form is y equals mx plus b, where m is my slope and b is my y-intercept. Whenever I see one of these, I automatically care about my y-intercept first because that gives me a starting point literally. So b, my y-intercept is -2. What does that mean? It's a y-intercept. So I go to my y-axis and I put a dot at -2 on the y-axis. My slope is also -2, making this problem friendlier. But I'm going to write my slope as a fraction because slope is rise over run. So instead of saying -2, I'm going to say -2/1. What that looks like is a line going up and to the left or down and to the right. You decide. So I'm going to build more points by going up 2, left 1, up 2, left 1. So let's go to my green dot. Up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. Uh-ohs, I ran out of room. Let's move my face. Now I can go down to right 1, down to right 1. Those are all my dots. Mr. Parrish, yes. Do I need all those dots? No, but I'm going to put all those dots there because it's impossible for me to draw a straight line. And I don't think this thing gives me any shapes. So I'm going to try to draw the straightest line I can and talk to you as I do it so there's no awkward silence. What a perfectly straight line. That's it. So when y is all by itself, life is good. You can draw it just fine. Everybody's happy. I didn't need to move my face. But, there you have it. Okay. Y equals stuff. The number in front of x is your slope. The number floating around is your y-intercept. But, make a little mark there. What if y is not all by itself? No big deal. Let's get y all by itself. Y is almost all by itself on the wrong side, but who cares? What I'm going to do is I'm going to look at the side that y is on and say, how can I get y all by itself? Well, y is being multiplied to 8. Let's divide by 8. It's very important to understand that when you divide both sides by a number, if you have multiple things going on the other side, you divide everything by that 8. So you cross out, you become 4, you become 2/8, divide numerator and denominator by 2, -1/4 x equals y. Now that looks kind of sloppy. Y is on the wrong side. It's not really in slope-intercept form. So let's write it out. Since I have stuff equals y, I can say y equals stuff. I have -1/4 x, so let me write out 1/4 x, -1/4 x, and 4 is positive. Now I can compare that to slope-intercept form, which is y equals mx plus b. So m, my slope, is -1/4. B, my y-intercept, is regular 4, and that's going to be my starting point. So I'm going to go up to regular 4 on the y-axis and put a dot there. Then I'm going to use that -1/4 to make more dots. Again, it's negative, so I'm going to go up and left or down and right. It's rise over run, so I'm going to go up 1, left 4. Up 1, left 1, 2, 3, 4, and I can't do it again because I run out of space. I can go back to my original point, and instead of going up 1, left 4, I can go down 1, right 4, and I can't do it again because I'm out of space. So let me get a new color. Let me make it a little bit bigger and try to draw a straight line. I had it until the very end. Okay, but that's how you graph a line when it's in not slope-intercept form. This is not in any form. This is in standard. It's not slope-intercept. I had to do a little bit of work to make it slope-intercept. Okay, but that's that line right there. There it is. Write the equation of a line that passes through -5, 6, and -7, 10. Use point slope form. I used to teach calculus at the college level, and point slope form is used more often than slope intercept form when creating equations. Point slope form is friendly because all you need is point and a slope and you're gold. Now here I have 2 points, no slope, no big deal. First things first, point slope form is this guy right here. Y minus y sub 1 equals m times the quantity x minus x sub 1. Where x sub 1, y sub 1 is a point. I have 2. Which point should I use? It doesn't matter. And m is the slope. So what I could do is I could label u x sub 1, y sub 1, because that's the first point that I see. And I can label u x sub 2, y sub 2. Now, why am I labeling u x sub 2, y sub 2? I have 2 points. I don't have a slope. I need the slope. So the way I can find the slope is by using the slope formula. So I'm going to write that out. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Oh, that's why I labeled these x sub 2 and y sub 2. Oh, now it's a matter of plugging things in. Y sub 2 is 10. So instead of y sub 2 parentheses 10, minus in the middle. I've heard of Malcolm in the middle, but minus in the middle. It's a show. Y sub 1 is regular 6, so parentheses 6. X sub 2 on the bottom left is -7, so parentheses -7. Minus in the middle. I've heard of monkey and forget. X sub 1 is -5. And now it's just a matter of simplifying. Okay, 10 minus 6 is regular 4. If you have a double negative, make it a positive. Looks sloppy? Sure does. -7 plus 5 is -2. And if you could simplify, do it. 4 divided by -2 is -2. So now I have my slope. I also have a point. So let's take this point right here and this slope right here, plug it into all that, and get my answer. Y minus y sub 1 is 6, so y minus 6 equals m, which is -2, times the quantity x minus x sub 1, which is -5. So the last step is just making that double negative a positive. So my final answer is going to be y minus 6 equals -2, parentheses x plus 5. Now, again, when I teach stuff like this, people ask me, well, what happens, sir, if I decide to call the second point x sub 1, y sub 1, and u x sub 2, y sub 2? You will get different numbers here. The slope will be the same. You'll get 2 different numbers. And if you're wondering, well, you mean you have 2 different answers? Yes. The trick is, if I were to take this, distribute that -2 out, and add 6 to both sides, I will end up with a unique slope-intercept equation. If I were to plug this point in instead of -5, 6, I would end up getting the same exact unique equation. So worrying about which point should I use for this point right here doesn't matter. It doesn't matter at all. And if you didn't know that, now you know. Write an equation in slope-intercept form. And point-slope form. First things first, the set of directions are different. I am given a point and a slope. Oh, God is good. But it's got to be perpendicular to that. So first things first. If something is perpendicular to a line, the slopes are going to be negative reciprocals to each other. So what's very, very, very important to understand is the slope that I care about is going to be the negative reciprocal of that guy right there. The negative reciprocal of negative 2 over 7 is positive 7 over 2. You take the opposite and flip the fraction. Okay, perpendicular lines have slopes that are negative reciprocals to each other. I also have a point. So it says slope-intercept form. Let's do that. Let's do that first. Okay, let's do slope-intercept on the left, slope-ini. And what that looks like is y equals mx plus b. Well, what do I know? I know that the slope is 7 over 2. So I'm going to write out y equals 7 over 2 x plus b. I don't know b. How can I find b? Well, I have a point, and what I could do is I can use that point, substitute it into that equation, and get a b. So that's what I'm going to do. My y value is 4, my x value is 2. So I'm going to replace y with 4, and I'm going to replace x with 2. And that gives me the ammo to find b. 7 over 2 times 2 means the 2's cross out, and I get 7. So 7 here, plus b on the right side, 4 on the left. Subtract 7, cross u out, and negative 3 equals b. Now that I have b, and I already know what's here in purple, I can put it all together and say y equals 7 over 2x plus b plus negative 3 minus 3. So back in Algebra 1 or Algebra 2 probably, more like Algebra 1, you were taught how to do this, right? And then I taught you slope-intercept form just a minute ago, and you're going to find out, like, what's the point of knowing both? Well, this wasn't too pleasant. I don't think so. I think point slope is very pleasant because point slope might be like 2 steps. I don't know. Let's write it out. Y minus y sub 1 equals m times the quantity x minus x sub 1. Oh, I already labeled my point. So y minus 4, because y sub 1 is 4, equals m. Oh, I already know what that is, 7 over 2. Times the quantity x minus x sub 1 is 2. And I'm done. So why in calculus do we more often than not use point slope form to write equations? Because it took us 2 steps, whereas this guy over here was a little bit longer and a little less friendly. Now again, if you're like, those are 2 completely different looking things, how do I know it's going to end up being the same? If I distribute 7 over 2 over there, right, that would give me negative 7. If I add 4 to both sides, adding 4 to negative 7 gets me negative 3. These 2 are the same. Trust me. Trust me. Trust me. Find the inverse. The inverse is literally the mirror image when you swap x and y. Graphically, and I don't remember if I have this here, graphically, if I were to give you a coordinate plane, right, and if I were to put a smiley face right here, the inverse is going to be like, well, I'm going to pretend that there is a mirror right here on y equals x. And so if that smiley face were to look at that mirror all crooked, it would end up looking like that. That's what the inverse is. Now, I'm not asking you to graph it, but the key thing here was y equals x. Okay, the inverse gives you a mirror image over y equals x. When you do an inverse, step number 1 is swap y and x. So that's what I'm going to do. Step number 1 when finding the inverse is swap y and x. So instead of y equals 3 halves x plus 5, x equals 3 halves y plus 5. Now my job is to solve for the new y. So step number 1 is let's subtract 5 from both sides. Okay, get rid of the constant first. X minus 5 doesn't combine, no big deal, x minus 5. That's going to equal 3 over 2y. Now I have to get y all by itself. So the way you get y all by itself is you could divide 3 over 2 from everything, but that's a mess. Instead, let's multiply both sides by the reciprocal. Multiply both sides by 2/3, so that those guys cross out, and now y is all by itself. 2/3 times x is 2/3 x. 2/3 times -5 is -10 over 3. Nothing fancy happens there. You're just multiplying them. Y is on the right, as you already know. I don't like that. So I'm going to swap them. Y equals 2/3 x minus 10 over 3. And the very last step is to put the little inverse symbol right there so that you know, and your teacher and the whole world knows that you just found the inverse. Step number 1, y is x, swap them. Step number 2, solve for the new y. Step number 3, turn that y into the inverse notation so that you know it's the inverse. That's how you find inverses. So pretty fun, huh? The answer is yes. It's a ton of fun. That's the end of part 1 here. Okay, we talked about solving equations, we talked about graphing linear equations, and we did a little inverse stuff going on here. So make sure that you move on to part 2 so that you feel a little bit more comfortable. I believe part 2 is about quadratics. So make sure you watch that as well. Don't forget to click that little subscribe button. Stuttered my words there, but the point got across. Oh, the point. Oh no, math. Thanks for watching. Bye. What up? Part 2 of getting ready for AP Precalculus. We're talking a lot about quadratics, how to factor them, how to solve them, which usually requires factoring, a little bit of quadratic formula, a little bit of graphing, awful, terrible, awful stuff like that. So let's just get started. Find the vertex of y equals x squared plus 16x plus 64. The vertex is the either minimum or maximum of a parabola. This is a quadratic because it's x squared. Since this is a positive x squared, it's going to look like this. The vertex is the very bottom of it. Now, when we have a parabola, a quadratic in standard form, which means x squared plus number x plus 64, the vertex is going to be, the x value is going to be -b over 2a. Okay, now if you remember quadratic formula, that should look a little familiar. We will do quadratic formula in a little bit though. Now this is just the x value. What's b? What's a? B is the number in front of x. A is the number in front of x squared. And just for funsies, C would be 64, but we don't have to worry about that here. So the x value of the vertex is going to be -b, which is 16, over 2 times a, which is an invisible 1. So -16 over 2, -8. Okay, now let me just write that out. X is -8. Now this gets me the x value and the x value only. I'm asking you to find the vertex, which insinuates that I want the point that would be the minimum in this case. So the way you find the y value is you just plug in -8 into that guy and do a little bit of math. So let me do that over here. Y equals, I'm replacing every x with -8, so -8 squared plus 16 times -8 plus 64. -8 times -8 is 64. Positive times a negative is a negative. This is going to be 128. And this is going to be positive 64. Oh, happy day. Why? Well, when I combine like terms, even though there's no like terms, I mean, like if I add these two together, I get 128. And then if you subtract 128, you get a big fat zero, a goose egg. So y, writing it over here, is going to be 0. Now, if x is -8 and y is 0, that means my vertex, which I'll denote as that little v over there, is -8, 0. Okay? And that's supposed to be a comma, but, I'm close. I'm just not perfect. Vertex. Fun, fun, funny, fun, fun. Now let's graph. The way that I'm going to graph this is it's a parabola. I do know that. This is a positive x squared, which means it opens up. I do know that. The last thing I want to do is pick a bunch of x values and assume that what I'm doing is no good. And what I mean is if I know my graph's going to look like this. Okay, but let's just say the vertex is like -840 and I didn't know that. So if I create an XY chart, right, and if I'm like, let's try 0, and let's try 1, and let's try 2, and let's try, you're finding all of these points over here and you will never get to the minimum. So the best thing to do is find out what the vertex is, find out the x value at least, and use that as your center, and everything to the left and everything to the right of it is just going to be symmetrical. So let's quickly find out the vertex. Again, the vertex is going to be -b over 2a. In this case, b is -2, a is invisible 1. So the vertex is going to be -2 over 2 times 1. Okay, doing a little bit of quick math. Negative is a positive. 2 over 2 times 1 is 2 is 1. So the x value is 1. So I'm going to make an xy chart where my middle x value is going to be 1. And then I'll also plug in 0, and then I'll plug in -1, and then I'll plug in 2, and then I'll plug in 3, and so on and so forth. So knowing that 1 is my middle, let's plug it in. The numbers aren't that bad. So I'll show you how to do it once, but everything from here on out is just going to be mental math. All right, so if I'm plugging in 1, y is going to equal 1 squared minus 2 times 1 minus 3. 1 squared is 1. -2 times 1 is -2, so 1 minus 2 is -1, -1 minus 3 is -4, so the 1 value is -4, and that gets me the point 1, -4. Just making sure, just doing the math in my head. Plugging in 0 is going to be pretty easy. You would go away, and that's -3. Now, here's the fun part about parabolas. They're symmetrical. So whatever you get over here, you're going to get the same exact thing over here. In other words, if I were to plug in 2, 2 would be, let me see, 4 minus 4 minus 3. Oh, it's -3 again. So at this point, you should be thinking to yourself, well, if I plug in 3, it's going to give me a number, and -1 is going to be the same thing. So if I do plug in 3, right, and let me show a little bit of work, not too much. If I do plug in 3, that'll be 9. If I plug in 3, that'll be -2 times 3, which is -6. And if I have -3, that's 9 minus 6, which is 3. 3 minus 3 is 0. So you're going to be 0, which means you are going to be 0. So let me graph what I have. -1, 0 lives right there. 0, -3 lives right there. 1, -4 lives right there. 2, -3 lives right there. And 3, 0 lives right there. Now, I have all this open space up here, and I'm wondering if I could fit plugging in 4, and I really think I can. I really think if I do that, I will get 5, but let's just double check. Let's add a 4, okay? And so I'm going to show just a teensy bit of work over here. Y equals 4 squared is 16. It's also a fun game. Minus 2 times 4, which is 8. minus 3. And so 16 minus 8 is 8. 8 minus 3 is 5. So 4 is going to be 5. So 4 is 5, which means negative 2, since everything is symmetrical, is also 5. Now it's a matter of me drawing this graph. And those of you who watched the previous section where I tried to draw lines, you know that this is not going to turn out well for me. So nice and smooth, nice and smooth, nice and smooth. Perfect. Nice and smooth, nice and smooth, nice and smooth, nice and smooth. Perfect. Tried to lean on the thing here and I missed and I slipped. That's why I went like that. All right, let's try another one. Let's see what else we have. We have, factor. Now, factor could mean multiple things. A factor could mean let's find a greatest common factor and bring that out. In this case, I don't have anything in common with these. More often than not in Algebra 2 and in pre-calculus, factoring means let me give you a quadratic and let's come up with two numbers whose sum is negative 7 and whose times is negative 18. Now, if that sounded like it was poor grammar, it is poor grammar. But the way that I remember how to do this is sometimes find two numbers whose sum, add, is negative 7 and whose times, multiply, product, is negative 18. Once you do that, you put them in these parentheses right here. There's nothing in front of x, so that's going to be an x here and an x here. Now, this is where it gets a little weird. First thing to do is find out what two numbers multiply out to negative 18. Do that first. If you try to sit there and come up with all the numbers that add up to negative 7, you're going to be there all day long. Start with a negative 18. So I know one's going to be positive and I know one's going to be negative. Now, whichever number is larger is going to be negative. Why? Because a negative plus a positive, if it ends up being negative, the larger number is negative. So two numbers that multiply out to 18 are 6 and 3. Could I take a 6 and a 3 and make them a 7 if I subtract one from the other? No. How about 2 and 9? Can I find a way to multiply 2 and 9 to get 18? Yeah. Can I find a way to subtract a 2 and a 9 to get 7? Yes. And so since this is negative, the 9 is going to be negative and the 2 is going to be positive. So if I were to check my work and FOIL this out, x times x is x squared. X times negative 9 is negative 9x. Plus 2x, negative 9x plus 2x is negative 7x, and 2 times negative 9 is 18. Hooray! Hooray! My daughter is playing my phone, so if you heard a an angel didn't get its wings. Somebody needs to turn the volume down a little bit. Sorry. It's all right. I love you anyway. Let's do it again. Okay? It's a quadratic. I need to come up with two numbers whose sum is negative 9, whose times is positive 8. Oh, they multiply to a positive but add up to a negative. That means they're both going to be negatives. Okay. Two numbers that multiply out to 8, 4 and 2. Negative 4 plus negative 2 is negative 6. No. How about 1 and 8? Negative 1 plus negative 8 is negative 9, so 1 and 8 it is. The order doesn't really matter. If I put x minus 8, x minus 1, good to go. Ooh, remember a minute ago where I said that if you have factoring, it could be one of several things. Like it could mean bring out a greatest common factor. Well, that's what we have going on here. I have a number in front of x squared, and usually you look at that and be like, oh, that's scary. I'm afraid. And maybe you should be. But in this case, don't be. Because I see a 7, I see a 45, and I see a 28. All of those are divisible by 7, which means I can factor out a 7, and that's what I'm going to do. When you factor out a number, you divide that number from all of these numbers, but leave the x's alone. Now, if I were to bring out an x, that's a different story, but that's not what I have. So if I divide 7 from 7, I have invisible 1. Drop down the x squared, because remember, leave the x's alone. That's a 2, but it looks bad. If I divide a 7 from negative 45, I have negative 9. Drop down the x. And if I divide a 7 from negative 28, I have negative 4. Now, usually I would look at this and be like, oh, a quadratic. Let's do sometimes. Let's see what two numbers add up to negative 9 and multiply out to negative 4. And then you think about it, and then you think about it, and then you think about it, and realize I can't. So does that mean that this is not factorable? No, this problem is factorable, and I already factored it, and that's just my answer right there. Sometimes factor means just factor out a greatest common factor, and that's what this was. Factor, 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 factor. Fear Factor, remember that show? Joe Rogan. How's he doing? Now, this is where it gets a little unpleasant, okay? And I'm going to be honest, I'm not super good at these, so you'll kind of see what it looks like to have a genius struggle just a little bit. I have a number in front of p squared. No big deal. There was a 7 in front of my variable squared last time, but there's no number in front of p, which means you can't factor out a number. Can I factor out a variable? No. So the only way that I can factor is by if you deal with factoring stuff with a leading coefficient. It's gross. I hate it. But it's a guessing game. Let's see what I do know. What I know is this multiplies out. It's still kind of like sometimes, but not really. This multiplies out to a negative 18. So you put a plus there, you put a minus there, because it's negative 18. Now, the nice thing is, since this is a 5, one of these has to be 5p, and one of these has to be regular p. I just don't know which one's which. Now, why is this 5p and why is that regular p? How else are you going to get 5p squared if I were to FOIL this out? Now, there's a problem. These signs might change if I chose the wrong parentheses. So that's something that we have to test out. Now what I have to do is I have to come up with two numbers that multiply out to negative 18. So if I do a 3 and a 6, let's see what happens if I put the 6 here and if I put the 3 here. Okay, I know it's going to be 5p squared. I know it's going to be negative 15 p and positive 6p, which doesn't work, not even close. So I don't like the 6 and the 3. And if you're like, well, swap the 6 and the 3. Swap them. If I swap them, then that's going to be 30 over here. No good. So the 6 and the 3, probably not a good idea. Let's try 9 and 2. So if I were to put the 9 here, I know that I would end up multiplying 5 times 9, which is 45. So I'm going to put the 2 here and the 9 here, and I'm looking at this thinking, this has promise. If I were to FOIL this out, 5p times regular p is 5p squared. 5p times negative 2 is negative 10p. 9 times p is positive 9p. And 9 times negative 2 is negative 18. When you combine these, you get negative p. We did it! Now, you might be thinking, because I did mention this earlier, what if for some reason I have plus p? And you're thinking, oh, I'm so close. What do I do? Switch the signs, and then you'll get it right. But I got it right on my second attempt. Good for me. Sometimes it's not as simple. You know, there's other methods that you can do this. One of them is called MUDs. I have a video on the YouTube where I call it the Nick Parrish method. I use a rainbow, but that is very tedious. If you use that method, it's tedious. I don't like tediousness. It's a sin. Now I have a solved problem. Now, when you solve a quadratic, you are dealing with something called the zero product property. I almost misspoke. Zero product property. What's that? If I have a parentheses and a parentheses, in fact, let me do this. If I have a parentheses times a parentheses and it's equal to 0, what you do is you set one of those parentheses equal to 0 and you set the other parentheses equal to 0 and you solve the stuff on the inside. What I'm going to do here is very much the same thing. Issue number 1, I need it to equal 0. So let's subtract 2 from the right side so it can equal 0. Erasing using the small eraser takes a while. Let's subtract 2 from both sides. -2, -2, cross u out. -2 doesn't combine with b squared or b, so I have b squared plus b minus 2 equals 0. Now it's a quadratic. I need two numbers whose sum is 1 and whose product is -2. Well, it's going to be b in here. One of them is going to be positive. One of them is going to be negative. 2 and 1, I can do 2 minus 1 to get invisible 1. So let's make the 2 positive and the 1 negative because it's 2 minus 1 giving us that invisible 1 that lives right there. Still equal to 0. Now remember what I wrote over here. You take each parentheses and set them equal to 0. b plus 2 equals 0 and b minus 1 equals 0. Subtract 2, b is -2. Interesting, the opposite of 2. Add 1, and b is 1. Interesting, the opposite of -1. So a little trick is if you're doing zero product property, and if what you have is a variable plus a number or a variable minus a number, your answer is going to be the opposite of the number in there. Okay, so I guess more appropriately, I can write this answer out as -2, 1. There you have it. That's what b is. Fun. Now it gets worse. Let me see. Let's do the same thing. I got to get rid of 65, so let's subtract 65n from both sides, not just 65 to 65n. Let me skinify the pen because I have a feeling I'm going to need space on this one. So that's 10n squared minus 65n minus 35 equals 0. I have a 5 in common in all three of them, so let's factor that out. Let's factor out a 5. If I divide 5 from 10, that's 2n squared. If I divide a 5 from -65, it's -13n. And if I divide a 5 from -35, that's going to be -7 equals 0. Let's see if I can factor that guy in there. I'm pretty sure I can. And if I can't, there's something that I can do, but I don't think I need to worry about that. Not right now. One of these has to be 2n. One of these has to be regular n. One of these has to be positive. One of these has to be negative. I'm feeling you have to be 7. You have to be 1. You have to be minus. You have to be plus. And that would give me 2n squared minus 14n plus n minus 7. I'm good. Now, as you do more of what I just did here, you'll kind of figure out the puzzle. And for me, it's all a matter of taking these numbers and thinking, look, I can only multiply 1 and 7, so I'm going to have to make sure I do 2 times 7 and 1 times 1, and that gets me the -13. But here I am. Here I am doing zero product property, and I'm actually going to show my work for 2 of these. I'm going to write out 5 equals 0, because technically 5 is in a parentheses, yippee. I don't need to do that, but technically it is. I have 2n plus 1, and I am going to be lazy. Because in the last problem I just said, if I have a number and a variable in a parentheses and you're doing zero product property, your answer is just going to be the opposite. So n is 7. Okay. Now going back over here to where it's blue, I wrote out 5 equals 0. Is 5 equals 0? No. So this guy right here, what's my solution? There is none. Ignore it. If you don't have a letter attached, you're not going to have a solution. That 5 is just kind of there to exist. Now I have here in purple 5n plus 1. So I actually have to do a little bit of math. Let's subtract 1 from both sides. That gives me 2n equals negative 1. Divide by 2, divide by 2, and n equals negative a half. So my two answers for this guy, are going to be 7 and negative 1/2, not in any particular order. It doesn't really matter the order that you have it in, but those are my two answers. Now, what if I did this guy? Got to that point right there, and I couldn't factor it. Does that mean there's no answer? No. There is an answer. It's just not factorable, so the answer is not going to be pretty. And that's when we have the quadratic formula. Now, the quadratic formula solves for any quadratic. What's that? A quadratic. In order to do the quadratic formula, you need it equal to 0, which it is. You're going to label the number in front of v squared a, the number in front of v b, and the number in front of nothing, that's just standalone c. Okay. Now, I have a song for the quadratic formula. It's a song. I wrote it. And if you steal it, I'm going to sue the heck out of you. It goes a little something like this. X equals negative b plus or minus square root b squared minus 4ac ac all over 2a. X equals negative b plus or minus square root b squared minus 4ac all over 2a. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, sir, we get it. Sing it again. No, I won't. By the way, my phone rang. If you're watching this 20 years from now, this is called an Apple Watch. I'm sure if you're watching this in like 2040 something, we've reached the apocalypse. Maybe, maybe not. All right. Get that out of here. X equals negative b. So b is negative 5, c is 3, and a is 2. So x equals negative 5. I'll clean that up in a little bit. Plus or minus the square root of b squared, which is negative 5, in parentheses squared, b squared minus 4 times a, which is 2, times c, which is 3. Extend that a little bit. All over 2a, 2 times 2. Now, when you're doing this, the first thing you're going to want to do is everything inside the parentheses first, inside the square root first, which is a set of parentheses. I didn't misspeak. Negative 5 is 5, though. I can just take care of that right now. So plus or minus the square root. Negative 5 squared is 25.
Daddy, can you put more weight on here? I'm sorry to update you. Little
Mermaid?
Yeah. I'm sorry for interrupting you. I'm sweaty.
You're sweaty?
Yeah. Because I'm sweating in Thank you.
Love you.
I love you too.
All right. Negative 5 squared was 25. Minus 4 times 2 is 8 times 3 is 24. Oh, God is good. God is good. You'll see why in a little bit. Over 4. Okay. Let's keep going inside that square root. Okay. That's going to be 5 plus or minus the square root of 1 all over 4. The square root of 1 is 1. So 5 plus or minus 1 over 4. Now what do I do? Well, I can clean this up. I can split this up into two problems. Okay? 5 plus 1 over 4 and 5 minus 1 over 4, because that's what plus or minus means. 5 plus 1 over 4 is 6 over 4, which is 3 over 2. Capiche? 5 minus 1 is 4 over 4, and 4 over 4 is 1. So x equals 3 over 2, and x equals 1, and that is my solution. Which means this problem up here is factorable. I could have factored it if I wanted to. I just didn't, because I wanted to get some quadratic formula practice in. Okay? Do I have another one? I don't. Now, there are times in Algebra 2 that you did quadratic formula and you probably ended up with imaginary numbers. That is possible. We're not going to see that a ton in pre-calculus. But again, the whole goal of this is making sure we know how to factor and know how to use the quadratic formula, because we will deal with what's called trig functions. And there are times where we have to do the quadratic formula every now and then. And so as an AP Precalc student, you are expected to know how to factor and how to use the quadratic formula. Also, completing the squares is going to be seen a lot in something called conic sections, which is graph that ellipse or graph that hyperbola or something like that. Graph the circle. You'll see stuff like that in pre-calculus too. You might have seen it in geometry depending on how far you got in geometry. All right, solving by completing the square means that you have to move certain things over, take half of something square, add it to both sides, perfect squares, blah, 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 blah. This is how you solve by completing the square. First things first, you need your variable squared and your variable on one side, and you need your constant on the other. I have my variable squared on the left. Ooh, my variable's on the right, but my constant's on the right. So the only thing that I have to do right now is subtract 8a from both sides. So I have my variables on the left and my constant on the right. So that gives me 2a squared minus 8a equals negative 6. Step number 2 is we have to get rid of the number in front of a squared. So we divide everything by that number, divide everything by 2. You go away and become a squared. Negative 8 over 2 is negative 4a. That's going to equal negative 6 over 2, which is negative 3. Now, I'm going to purposely leave myself some space, and you will see why. Over here, too, negative 3. Now, to complete the square, what you do is you take half of the number in front of a, so negative 2. You square that, so positive 4, and you add that to both sides. Okay? And so that leaves me with a squared minus 4a plus 4 equals 1. Every single time that you do this, this will happen. You will get a perfect square on the left. So I can factor this using sometimes, but when I do, it will always be a perfect square. So two numbers that add up to negative 4 and multiply out to positive 4 are negative 2 and negative 2. So a minus 2 squared equals 1. Again, if I don't have a perfect square, I did it wrong. How do you solve for a square? Square root both sides. Do not forget that when you square root both sides, the side that is the number is going to be positive or negative. That crosses out, and we have a minus 2 equals positive or negative square root of 1, which is 1. I add 2, and now a equals positive or negative 1 plus 2. You split this up into two problems, okay? Where you have positive 1 plus 2, 3, and negative 1 plus 2, 1, and those are my two answers. Which means this problem is very factorable, but we did completing the square because I wanted you to see the process. You got to trust it. Trust the process. Sixers. Did I skip one? Find the zeros is just a fancy way of saying make f of x 0 and solve. So I'm going to do that. I'm going to make f of x 0, and I'm going to write out x squared cubed minus 2x squared plus x. I have to factor this out. Oh, look, there's an x in common and everything. Let's bring out an x. So when you divide out a variable, which we haven't done yet in this video, if you divide out one variable, you subtract each degree by 1. So x cubed is now x squared. Nothing happens with negative 2. X squared is now just x, and if I divide an x from an x, I'm left with an invisible 1, or I'm going to write out the 1. Can I factor that guy out? Yeah, I can. 0 is going to equal x. Two numbers that add up to negative 2 and multiply out to 1 are going to be x minus 1 squared. So using the zero product property, I have x equals 0 because you set each, remember you can pretend that that's in a parentheses, so x equals 0, and x minus 1 squared equals 0. Square root both sides, positive or negative, square root both sides, cross you out, x minus 1 equals the positive or negative square root of 0 is positive or negative 0 or just 0. Add 1 to both sides, and x equals 1. So my two answers are 0 and 1. Now, what I should have done and what I could have done is I noticed that x minus 1 is being squared. I didn't need to go through all of this. I could have just said, isn't that just going to be the x minus 1? The opposite of negative 1 is positive 1, and that's my answer? Yes. Some teachers might have you say that the multiplicity is 2. That just means you use 1 twice, technically. But, we're not going to lose any sleep over that. Some people also say double root. But there you have it. All right, this is my last one of section 2. We have to graph this. Now, I'm not getting a calculator. I probably should have used the word sketch, which means I know very well that my picture is not going to be 100% perfect. And that's okay. The only perfect person is Jesus and me. And my little 5-year-old that you saw earlier. Isn't that right? She shook her head yes. So when I graph this, I noticed right away that this is a cubic. The leading coefficient is positive, and positive cubics look like this. Okay, positive cubics look like that. What I'm going to do is I'm going to keep that in mind and keep that off to the side. Nothing to factor out. Can't do factor by grouping. No zeros in common that I can tell right away. I'm just going to have to do this off the old dome. So what I'm going to do is I'm going to make an X, Y table and include a ton of numbers. It's going to be tedious. That's all right. Let's do -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. And if I have to add more, then I'll add more. And we're going to do a lot of this using mental math. Okay. And in fact, if I realize right away that some of these won't fall on the graph, I won't go any further. And what I mean by that is when I plug in negative 5 to the third power is negative 125. So if the number is just going to be like 80, and I realize that immediately, I can't graph 80. I'm just going to quit right there. So for example, if I plug in negative 5, I'm going to get negative 125 because negative 5 times negative 5 times negative 5 is negative 125 plus 25 because negative 5 times negative 5 is 25. And then minus negative 5, no. Number's going to be huge. I'm not doing it. If I plug in negative 4, that's going to give me negative 64 plus 16. Minus negative 4 is plus 4. Minus 2, again, too big. No. If I plug in negative 3, I get negative 27 plus 9. Minus negative 3 is going to be plus 3. And then minus 2. So that's going to be negative 17, I think. Either way, too big. Now it's probably going to be manageable because I went from huge numbers to negative 17. I'm getting to the point where I should be able to graph it soon. If I plug in negative 2, okay, I'm on negative 2 now. If I plug in negative 2, I'm going to have negative 8 because negative 2 times negative 2 times negative 2 is negative 8. Negative 2 times itself is going to be positive 4. Minus negative 2 is going to be plus 2 minus 2. So this ended up being negative 4. So that is certainly manageable. Okay, certainly manageable. By the way, this is going to be a really big, what did I say this was? Negative 17? But I already knew that it's going to look like that. So that's I just waste my time there. If I plug in negative 1, I'm going to have negative 1 times itself is negative 1 plus 1 minus negative 1, which is plus 1 minus 2. So 2 minus 2 is 0, minus 1 is negative 1. If I plug in 0, you all go away and I get negative 2. If I plug in 1, I get 1 plus 1 minus 2 is negative 1 again. If I plug in 2, I get 8 plus 4 minus 2, which is 8. If I plug in 3, I get 27 plus 9 minus 3 minus 2. The numbers get huge. So these are going to be no good, no good, no good. Numbers are just going to be too big. So these are really the only points that I have going for me, all 6 of them. Okay, so I have negative 2, negative 4, which is going to be negative 2, negative 4 right here. I have negative 1, which is right here. I have 0, negative 2 right there. I have 1, negative 1 right there. And I have 2, 8 way up here. Now, I know this isn't perfect, right? And my job here is not for perfection, but is to get a somewhat accurate picture. And this is a somewhat accurate picture. In pre-calculus and in regular calculus, you will be able to find out the exact points where these things peak out and bottom out, but we're not going to worry about that here. You will also learn how to do that in pre-calculus. So if you're like, how do I know that's not the maximum? How do I know that that's not the minimum? It may not be. But I'm not going to worry about that right now. I'm just getting a general idea of what this graph looks like, and I'm all right with it. So, section 2 was mainly about quadratics. We had a trinomial here, or a cubic, not a trinomial. We had a cubic here. There's going to be 3 more sections that we're going to look at before we deal with the end of getting ready for AP Precalculus. So, keep on watching. Make sure you rewatch this again if you're not sure. And thank you. And don't forget to hit that little subscribe button. Make me some money. please. Bye. What up, what up? Welcome back to Let's Get Ready for AP Precalculus, and we're on part 3, which deals with square roots and rational expressions. Pardon my language, but AP Precalculus has a butt-ton of square roots. A butt-ton of square roots. And so it's very important that we know how to add, subtract, multiply, divide, square roots, and that also brings us rational expressions. A butt-ton. So make sure that if you're going into pre-calc and your square root game is weak, you better step your game up, because you're about to get dunked on in the face. Of course, if I'm talking to a bunch of AP Pre-Calc students, you probably have zero clue what sports references I'm talking about. You're probably like, I play chess. Gotcha. Oh, we have fun. I'm just joking with you. Kinda. Square root, let's simplify it. Well, the long way of simplifying a square root, and by the way, I call this the Nick Parrish method of simplifying square roots. You might have done this differently with a different teacher, but my method is the best. If you need to go off to the side and make yourself a factor tree, this is not a matter of like, let's plug it into our calculator and it's going to be like 4.9-ish. No. You make a factor tree and you find the prime factorization. So two numbers that multiply out to 24, how about 4 and 6? Neither of them are prime. Let's keep going. 2 and 2, circle the 2, circle the 2, circle the 2, circle the 3. You write that whole square root as its prime factorization. I already have it in order. 2 times 2 times 2 times 3. You look for pairs and bring one of each pair out. I have a pair of 2s, no more 2s, and I only have 1 3. So you bring 1 2 out and you multiply what's left over on the inside, and you're done, baby. You're done. Now, some teachers might have you do something like this. It might look like this, right? It might look something like this. In which case you'd be like, the square root of 4 is 2, and then you have 6. It all depends on what kind of teacher you have. But the Nick Parrish method of doing square roots is so much better than whatever dumb teacher you had in the past. Okay, trust me on this one. Trust me, I'm looking back because my 5-year-old's in the room and I said, dumb? Is dumb a curse word? She said, no. Yes, it is? Great. Now I can't make this safe for kids. I wasn't going to anyway. All right, so, cube root. So cube root follows the rules a little bit differently. That is an eraser. That is a pen. So let's cube root it. I don't need to make a factor tree for 16. I know, first off, negative. 16 I know is going to be 2 times 2 times 2 times 2. Who wants to be annoying? Me. A times A times A. Okay. B times 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 B 1 2 3 4 5 6 7 times B. Now, since this is a cube root, I am circling groups of 3. In a cube root, you're allowed to have a negative. Bring it out. I have 1 2 3 4 2s, so let's pull out a group of 2 of them. I have 1 2 3 A's. Let's pull out a group of 1 of them. I have 1 2 3 B's. Let's pull out 1 of them. And I have 1 2 3 B's, and let's pull out 1 of them. And I have 2 B's left over. Or not 2 B's. Shakespeare. What did I pull out? A negative, a 2, an A, a B, and a B. So a B squared. What do I have left over? 2 times no A's times 2 B's, so 2B squared. Don't forget the cube in your cube root. Same rules apply for 4th roots and 5th roots and stuff like that, but we're not going to lose sleep over it. Let's see if we can simplify these guys first. The way you would combine like terms if they're square roots is you would combine them as if they're regular like terms. Like if you were an A and if you were an A, then we would do like negative 4A. Oh, but you're not. You're a root 45 and you're a root 20 and you're a root 6. And you might be thinking to yourself, can't you fix 45 and 20 and bring stuff out like the guy did before? Yes. 45 is 9 times 5. So let me write that out as 3 times 3 times 5. 20 is 4 times 5. So let me write that out as 2 times 2 times 5. 6 is 2 times 3. Can't do much there. I can bring out a group of 3s and multiply it to that negative 2, and that gives me negative 6 and leaves me with the square root of 5. I can pull out a group of 2s and bring that out and multiply it to that negative 3 and get another negative 6, and I'm left with the square root of 5. And then I have 2 times 3, which does nothing. 6, just 6. What can I do with you? Nothing. What can I do with these guys? Combine them. Negative 6 root 5s take away 6 more root 5s is negative 12 root 5s. And then minus 2 root 6. That's how you simplify it. Right? Right? Okay. When you multiply square roots or cube roots, what you do is you multiply from within the roots and you keep that root the way it is. In other words, this is a big third root of 3 times 9, which is 27. Well, wait a minute. 27 is 3 times 3 times 3. This is a cube root. Circle a group of 3s, bring it out. What do I have left over? Nothing. What's my answer? 3. Dunzo. When you multiply roots, you multiply the insides and create one big root. Okay, also known as a radical, and this was a cube root. Let's do it again. Now, this is distributed property, which means multiple multiplying. So I have 4 times no number, which is going to be 4. I have the square root of 15 times the square root of 6, which is the square root of 90, because 15 times 6 is 90. Okay? I have 4 root 15 times root 5. 4 times no number is positive 4. Root 15 times root 5 is 75. Let's rip this apart. Okay, 9 times 10 is going to be 3 times 3 times 2 times 5. So 2 times 3 times 3 times 5 plus 4. 75 is 3 times 5 times 5 because it's 3 times 25. This is square root, so circle a pair of 3s and bring it out. 4 times 3 is 12. What's left over? 2 times 5, which is 10. This is square root, so circle a group of 5s. 4 times 5 is 20. Circle a root 3. Can I combine these? No. Am I done? Yes. Yes, I is. Foil. Foil. Root 3 times root 3. I already know what's going to happen, but let's just write it out anyway. Root 9. Root 3 times negative 5. Root 5x is negative 5 because, negative 5 is living on the outside. Nothing combines with it. 3 times 5x is going to be 15x. Root 5x times root 3 is going to be positive root 15x. Oh, how convenient. And root 5x times negative 5, root 5x is negative 5. Root 5x times root 5x is root 25x squared. You might be thinking, stupid pants. Oh, Okay, my 5-year-old's in the room. I don't know if I brought that up yet. Stupid is a bad word, isn't it? Yeah, I'm sorry. It's twice. Strike 2 in one video. I apologize. I apologize. I apologize. You just said it.
Don't say it again.
Yes, ma'am. You're thinking, silly guy with a hat. Root 3 times root 3, when you square a square root, they just disappear and you end up with 3, right? Mm-hmm. And just, I wanted to show everything and make sure everybody's good with that. There's nothing I can do with root 15x. So negative 5 plus invisible 1 is going to be negative 4, and then root 15x just comes along for the ride. And then I have negative 5 times, wait a minute, the square root of 25 is 5, and the square root of x squared is 5x. Couldn't you just have figured that out at the very beginning when you said root 5x times root 5x, you're squaring a square root, which just makes a 5x? Yes. Too late. This gives me 3 still. This gives me negative 4 root 15x still. And this gives me negative 25x. Those are 3 different terms that don't combine. I am done. Done. Now, here's the issue with this guy right here. You're not allowed to have square roots on the bottom of a fraction in the denominator. You are going to see this a lot in pre-calculus where you're going to have square roots in the denominator. You're going to see it a lot. You're going to see it a lot. And this is what you do. If you have just a square root or 3 times a square root in this case, the way you fix that problem is you multiply the top and the bottom by root 5 over root 5. What that does is it still gives us a square root on top, which we don't care about, but it gets rid of the square root in the denominator. So we take whatever square root that is, if it's just one term, no adding, no subtracting, whatever that guy is, you multiply that to the top and the bottom. So we multiplied root 5 to the top and the bottom. When we do that, that gives us 4. 2 times root 5 is root 10. Root 2 times root 5 is root 10. And on the bottom, we get 3 times root 5 squared, which is 5. Cleaning that up gets us 4 root 10 over 15. Now, before you get all excited and think, oh, 2 over 3, 2 over 3. No. Stop it. No. This is inside of a square root, and that is not. So you can't simplify them. 4 over 15, you can't do a thing with, this is my answer, I'm done. So again, you are going to see it a lot where you're going to have a single term in the denominator. And the way you get rid of a square root in the denominator, if you have a single term, is you multiply the top and the bottom by that square root. It's going to happen a lot in pre-calculus. Okay? Now here's the issue. What if I'm adding or subtracting on the top or the bottom? You see, if I multiply the top and the bottom by root 2, I would distribute that, and then 5 becomes 5 root 2, and you're in the same exact position that you were in before. Okay, if you are adding or subtracting in the denominator and you have a square root in the denominator, what you do is you multiply the numerator and the denominator by what's called the conjugate. And the conjugate is whatever guy that is, but flip the sign in the middle. This is difference of squares. And difference of squares means a square minus a square. And the nice thing about a square is it can't be a square root. Because if you square it, the square root goes away. So difference of squares is a square minus a square, which means no more square roots. So the top I have to do the same thing to. 5 minus root 2. So the top guy is distributed property, and the bottom guy is FOIL. So the top guy is going to be root 5 times 5, so 5 root 5. Root 5 times negative root 2, so minus root 10. The bottom is FOIL. Magical things are going to happen. 5 times 5 is 25. 5 times negative root 2 is negative 5 root 2. Root 2 times 5 is positive 5 root 2. Remember that magic I was talking about earlier? And root 2 times negative root 2 is, well, root 2 times root 2 is 2, because it's root 2 squared. And so it's negative 2, minus 2. Can't combine the top. You're a 5, and you can't simplify those square roots. So it remains 5 root 5 minus root 10 over, you guys go away, and 25 minus 2 is 23. It's called rationalizing the denominator. What you're really going to want to know from what we just did is what we saw here with the root 5 over root 5. All this stuff is very important, but this is probably the most important. So thank you for watching. Bye. What up, what up? Part 4, we're going to talk about right triangles and Pythagorean theorem. Now, with everything we do today, we are not going to use a calculator. Calculators are for noobs and simps. I am neither of those. Next section, we'll use calculators, though. Then it won't be for noobs or simps. I don't know what a simp means. Saw it on the internet once. Find the missing side. What we have here for ourselves is a right triangle where we are missing the longest side of the right triangle. We all know from Algebra 1 that if I give you a right triangle, we're going to call the longest side C. It's also called the hypotenuse, and we're going to call one of our legs A, and we're going to call another one of our legs B. And you can use the Pythagorean theorem to solve for any missing side of a right triangle. Okay? Over here, same thing. We're going to use Pythagorean theorem. Now, what I have to do is, it doesn't really matter which one of these is the A or the B, as long as the longest side is C. So I'm going to call X C, I'm going to call 4A, and I'm going to call 3B. Okay? And then you just plug it right in the Pythagorean theorem. A is 4 squared. A fun game to play. Plus B squared, 3 squared, rhymes. Equals C squared, I don't know. Now let's square. 4 squared is 16. 3 squared is 9. C squared is still C squared. Combine like terms. 16 plus 9 is 25. That equals C squared. Is C all by itself? No. Square root both sides. Now, normally, when you square root both sides to solve, the side with the number gets a plus or minus sign, but not here, because that would be like saying, yes, the answer is going to be negative, blah, blah, blah. And you can't have negative measurements for sides. That's silly. So C is going to be 5. And in this case, since the problem that I have is X, and since it also gives us miles, I'm going to make sure I answer this nicely. X equals 5 miles. Now, I would walk 500 miles, and I would walk 500 more. But this answer is just 5 miles. That is, by the way, a song. Don't remember who sang it, though. It'll come to me, I think. Hopefully by the end of the video, I figured out who sang that song. I could look it up on the internet, but the internet's for noobs and simps. Find the missing side. Again? Well, same exact rules, kinda. I have myself a right triangle, so I'm going to call the longest side C. It doesn't matter which one's A or B as long as the longest side is C, so I'll call you A and I'll call you B. Let's write out Pythagorean theorem. A squared plus B squared equals C squared. All right. Let's get this out of the way so I can see that. I called A 12, so 12 squared plus B squared is going to equal C, which is 13 squared. 12 squared is 144, plus B squared, which is still B squared, 169. Is B all by itself? No. Now, in the last problem, I had a square plus a square. I actually added the numbers together. That's when I was finding the hypotenuse. I'm not finding the hypotenuse here. I'm trying to find a missing leg. So it's not, let's add them and square root them. I have to do a little bit more. I actually am going to subtract 144 from both sides, so minus 144, cross u out. Drop down the b squared, drop down the fact that that is, no, 25 again? So let's square root both sides again, and we'll get 5 again. And let's remember that you can't have a positive or minus sign because you can't have a negative length again. And that gives us b equals 5. Now, the original problem is x, and the original problem has inches. And so x is 5 inches. Okay. We're on a roll. Now, normally, you would look at this and you would say, yes. We have ourselves another right triangle. Let me get out my Pythagorean theorem. No. Here, I only have one side, so the Pythagorean theorem is useless. What I also have is the fact that that's 45 degrees right there, which would make you 90. I knew that. But that would also make you 45. Now, much of what we did so far up in these videos was just Algebra 2 stuff. In fact, I don't think anything we did was not Algebra 2 stuff. Pythagorean theorem you see in Algebra 2. Now we are going into geometry territory where we are no longer doing Algebra 2. We are now doing geometry. Pre-calculus takes Algebra 2 stuff and geometry, mushes it together, and makes you get ready for calculus. So now we're in geometry land. And geometry land says we have a couple special triangles, and this is one of them. Okay, when you have a 45, 45, 90 triangle, you can find the measures kind of easily. And so since this is a 45, 45, 90, that means this is isosceles. Those angles are the same, which means these sides are the same. So whatever side this is, A, and that's just an arbitrary value, you're going to be the same exact thing, which means finding y is going to be very easy. Now, how do we find the hypotenuse? Should I do Pythagorean theorem now? No. You could, but no. Because in a 45, 45, 90 triangle, whatever A is, the hypotenuse is going to be multiplied, or you multiply the square root of 2 to any of the legs. So again, this is a 45, 45, 90 triangle. And in a 45, 45, 90 triangle, you have a leg is A, another leg is A, and the longest side is the leg times the square root of 2. So, your leg, your 3 root 2. What is y? The same exact thing. Y is going to be the same as that, so y is also 3 times the square root of 2. Now I need to find x. What is x? X is going to be one of the legs, 3 root 2, times the square root of 2. And we know that when you multiply square roots together, you multiply the inside. So this becomes 3 times the square root of 4. Oh, I know what the square root of 4 is. It's 2. And so 3 times 2 is 6. So x is going to be 6, and y is going to be 3 times the square root of 2. That's a box. That's a circle. Don't know why I did that. 45, kind of 45, 90, donezo. Are there any other types of special triangles, sir? You ax? I don't know. I guess we'll find out right now. There is another type of special triangles. Another type of special triangle. What we have here is we have a right angle. Got it. We have 30. Got it. Which would make you 60. Oh, this is the 30, 60, 90 triangle. The way you handle a 30, 60, 90 triangle is you locate the smallest leg. The smallest side we'll call you A. The smallest side is always going to be the side attached to the 60 and the 90 degree angles. The other leg, what you do, very similar to the last problem, is you multiply the square root of 3 to it. Okay, so whatever the small leg is, multiply the square root of 3 to get the other leg. What's the hypotenuse? You take the shorter leg and multiply it by 2. Okay, so when I look over here, 2 represents A, the shorter leg. V represents the longer leg, so V is going to be 2 times root 3. I don't have to do anything. U is going to be 2 times this shorter leg, 2. Let me get out my calculator. 2 times 2 is 4, so U is 4. V is 2 root 3. Not bad. Not bad at all. Now, this is where things get a little bit more complicated. Now, the reason why we are doing special triangles to get ready for pre-calculus is for something called the unit circle. With the unit circle, we talk about two main types of triangles, a 30, 60, 90. Okay, 30 degrees and 60 degrees are insanely important for trigonometry and pre-calculus. And we also will see the 45, 45, 90 triangle every now and then in the unit circle as well. Okay, very, 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 very important stuff. Now, the two problems that we did was basic. Okay, if you remember geometry, you're going to be like, oh yeah, I got it. I understand. This is where things get a little bit more complicated, and this is where you're going to really see things in the unit circle. I have a 30, 60, 90. Okay, and I'm going to draw a picture over here that's going to be very, very, very similar. Here's my 60. There's my right. There's my 30. Whatever the shorter side is, the longer side is going to be 2 times that, and the longer leg is going to be a root 3. Now, what I had in the last problem is I gave you the shorter leg. And so all you had to do is attach the root 3 and then multiply by 2 and you're done. Not the case, not the case at all. What we have here is I'm giving you the hypotenuse. So let's think logically, okay? Let's think logically. If the hypotenuse is supposed to be 2 times the shorter leg, then the shorter leg is going to be half of the hypotenuse. In other words, half of 10, which is 5. So y is 5. What does that make x? If y is 5, x you're going to multiply root 3 to 5. So x is going to be 5 root 3. Okay? So that wraps up the right triangles and Pythagorean theorem part of this video. I think if you do geometry, you will get to this part. The next part, part 5, is the intro to trigonometry. Now, many of you may not have gotten to trigonometry in geometry class, and that's okay. If you watch part 5 and you're like, I've never seen this before, just watch it, pay attention. Very important. You're going to see a lot. But that's part 4. Part 4 is Dunzo Funzo. So as always, I love you. Subscribe. Thanks for watching. Bye. What up, what up? Welcome to part 5 and the last part of Let's Get Ready for AP Precalculus. Now, I'm going to be honest, full disclosure, I am a high school math teacher. This is the first year that anybody is taking AP Precalculus, the year 2023. But 2 years ago, I taught geometry, and many of those same exact kids are coming back to me for AP Precalc. But also 2 years ago, we were just getting out of COVID. We had to shut down for a week. We had to have some virtual days. We had to, do certain things to get back into the flow of things. So I, as a geometry teacher, did not get to get to trigonometry, which is what we're about to do. Now, if you've never seen this before, and this might be the first time you're seeing it, please keep watching. If you've seen this before, bring it all back. Trigonometry is all over pre-calculus. Pre-calculus is dominated by trigonometry. So whether this is the first or 15th time you've seen trigonometry, follow along. It'll be good for you. Now, what I have here first is a right triangle. Now, in the last video that I have, we did a lot of Pythagorean theorem and 45, 45, 90 triangles and 30, 60, 90 triangles to find missing sides and stuff like that. What this does, trigonometry, is this replaces those if I don't have pleasant angles. Like if I don't have a 30, what if I have an angle of 43.2 and you don't have any shortcuts for that? Well, over here on the left, you see SOHCAHTOA. SOHCAHTOA takes care of all that. Now, before we look at SOHCAHTOA, we need to look at this right triangle first. Okay, this little angle is denoted by the Greek letter theta. Okay, my angle, that's not a zero. My angle measurement is going to be given to me by the Greek letter theta. And I have to compare these sides to the angle theta. So when I look at theta, what is that long side right there? Well, it's always the hypotenuse. Don't lose any sleep over it. Hypotenuse, bada bing. When I look at theta, what is that side over there? That side is the opposite side to theta. And when I look at theta, what is this side right here? That's the adjacent side. Now, if you're thinking, isn't hypotenuse also adjacent? Yes, it is, but the hypotenuse is always the hypotenuse no matter what. Now, SOHCAHTOA is an acronym, and my three trig functions are sine, cosine, and tangent. So this obviously means sine something. What does it mean? Well, sine stands for sine theta equals the opposite side, and I'll just abbreviate it, over the hypotenuse. Okay, so if for some reason I told you I need to find that angle, and I've given you the opposite side and the hypotenuse, you are going to use sine. Ca, which is what I call my friends, stands for the adjacent side over the hypotenuse. So we will say cosine theta equals the adjacent side over the hypotenuse. Last but not least is the tangent. And the tangent, OA, you probably guessed it, is going to equal the opposite side over the adjacent side. Okay, now these three trig functions, sine, cosine, and tangent, and I know you're like, isn't that sin? No, we don't listen to sin. We don't believe in it. This is sine, and that is not cos, all right, like the Cosby. No, that's cosine, and that's not tan, like what I'm getting during this summer. That's tangent. Okay, these are all abbreviated for trig functions. And unlike the last chapter where I called you all Simpson noobs for using calculators, we are going to need calculators. Now, I'm going to be using Desmos, and you have to make sure that you click on the little, the wrench here and set it to degrees. So if you see me go off to the side, it's because I'm using my calculator. If you're using a TI or a Casio or some kind of graphing calculator, make sure you have that set to degrees, and usually you click mode and you set it from degrees. The other option is radians. Don't choose radians. In pre-calculus, we will deal with radians, but in geometry, we're not. Okay? So, find the trigonometric ratio. So we're starting out simple. We're starting out friendly. Okay, it's asking me to find the tangent of x. Not even find it. It's asking me to find the trigonometric ratio. So I'm thinking, oh, tangent. SOHCAHTOA. So what I need to find, the tangent of x is going to be TOA, the opposite side over the adjacent side. Let's go to our right triangle. X is this guy right here. I need to find the sides based off of my angle right here, and I'll even put the angle X in there so you can see it a little bit better. I care about the opposite side that is opposite to X. That would be 32. So 32 is my op. Also, which one's my adjacent, 40 or 24? Well, 40 is the hypotenuse, and the hypotenuse is always the hypotenuse, so it's not you. It's going to be you. Okay, so tangent of x is going to equal my opposite side, which is 32, over my adjacent side, which is 24. And depending how picky you want to be, I can go one step further. And I'm going to keep it as a ratio. I'm going to keep it as a fraction because it says ratio in the directions that I created. If you divide both of those by 8, you get 4/3. So that's what tan x is. Okay. Right now, all I'm doing is finding the trigonometric ratio. I'm not solving for x. We will deal with that soon enough in this video. Find the trigonometric ratio again. Okay, let's make one up. I didn't have anything. Let's do sine A. Okay. Sine A. So katoa, so S-O-H, so katoa. The so part stands for the sine of my A is going to equal the opposite over the hypotenuse. The opposite over the hypotenuse. So let's find A. Again, this is all in relation to what angle I'm dealing with, and we're dealing with A. So I need to find the side opposite of A, and it's 32. So we'll do opposite right there. I also need to find the hypotenuse, and the hypotenuse is always the hypotenuse, 40. Okay, so sine A, no, I can't use that color. Sine A is going to be my opposite side, which is 32, over the hypotenuse, which is 40. Again, the same exact numbers it seems like we had last time. They're both divisible by 8, so not the same exact numbers, but very 80 numbers. Divide both of them by 8, you get 4/5. So that's the trigonometric ratio. Okay? So I didn't find anything. I didn't solve for any angles or anything like that. Usually when I give you a problem like that, if I'm asking you to find the sine of something, the whole goal is to find out what the measurement of that angle is. Not yet. Soon enough. Be patient. Now, this is how we would do it. Let's say that I want to find the angle measure. Let's say that I give you a right triangle and I say, find the measure of W, and you do a similar process to what we just did, where you have a letter over a letter, or a number over a number, and you get that, and now you need to get W all by itself. If you want to get an angle all by itself, what you need to do is something called the inverse trigonometric function. In this case, the inverse cosine. And what that looks like is this. That's supposed to be an S, cosine with a little inverse thing to it. Some teachers use this. It's called the arc cosine. There's also an arc sine, an arc tangent. There's the same thing here. There's also an inverse sine and an inverse tangent. We're going to use that always, so I'm going to get rid of it right now to get rid of all the confusion. Now, how do I get rid of W? The opposite of cosine is inverse cosine, and you do that to both sides. Inverse cosine, both sides. Okay, put that in parentheses because it's proper. Put that in parentheses because it's proper. It's very similar to like dividing both sides, but we would never say divide both sides by cosine. That's a completely different animal that you are going to see a lot in pre-calculus. Cross you out, W is all alone, hooray. Now, what the heck is the inverse cosine of 0.6157? I don't know. So what we do is we run to our calculator, and whether you're using a Desmos or whether you're using a TI-80, whatever, which I do have. Do I have batteries in it, though? Ugh. Oh, no, it's a TI-89, titanium. Batteries are dead. So you would look at this, and maybe you can see it, maybe you can't. The inverse cosine is there in green. So you would hit like this little green button, and you would hit the inverse cosine button. If you have a TI-84 or a TI-80 something, which I should have, but I don't remember where I put it, you would use that to, can't find it. So what I'm going to do is I'm going to go to my Desmos and I'm actually going to type in inverse cosine, or I'm just going to hit the functions button and find inverse cosine, which is pretty much right away, and type out 0.6157. Okay, I don't know how well you can see that. There you go. And I'm just going to hit enter. And it's going to definitely not be a pleasant number. It's not, but it looks like it's roundable. So 51.997, which I'm just going to round up to 52 degrees. Remember, whenever we take the inverse sign to solve, we are finding an angle measurement. That's the goal. That's the point. If for some reason you didn't get 51.997, it's because your calculator is set to radians, set it to degrees. Okay? Done. Now, this is where inverse trig functions, all the stuff that we did so far, become very, very, very important. My goal is to find the missing angle here. Let's call it theta. Okay? We're going to do this. Probably the most important part about pre-calculus is what we're about to do. So make sure if you're watching this and seeing it for the first time, rewind it, watch it again, watch it again, watch it again. My goal is to find theta. Okay? Theta is important to me. So I'm thinking SOHCAHTOA thoughts. And what I need to do is I need to figure out how and is 9 and 21, 9 plus 9, how is that related to theta? Okay, if I look at theta, what is 9 to me? Well, 9 is the opposite side. If I look at 21, 9 plus 10, what is 21 to me? 21 is the adjacent side. Okay, so I need to figure out which trig function I'm going to use based off of the fact that I'm given the opposite side and the adjacent side. So I need the one with the OA, and there you is. So I need tangent. So let's set it up. Tangent of theta is going to equal, leave myself some space, the opposite over the adjacent, 9 over 21. If you're wondering, why did he whisper kind of to himself, leave some space? Because I need to find theta. I don't have theta. I have tan theta. Tan's in the way. How do I get rid of a tan if the tan is blocking theta from being alone? The inverse trig function, and I'm going to do that to both sides. So I'm going to inverse tan both sides. Look at me leaving some space. That crosses u out, and theta is now by itself. What I do is I run to my calculator or to my Desmos, and I type in the inverse tangent of 9 divided by 21, and it gives me 23.19859. So I'll do 23.199. Okay, 23.199. Now this is theta. I didn't use theta originally, so to make sure that I'm a purist, I'm just going to say the missing angle is 23.199 degrees. So that's what trigonometry is used for. Trigonometry is used to find missing sides or angles, and in this case, an angle, if I'm not given a ton of information. And that's what I got. It's a missing angle. Find the measure of the missing angle again. So the same exact rules apply. I'm thinking SOHCAHTOA. I'm looking at that question mark. I'm going to call you theta. Theta compared to 42 is my hypotenuse. My hypotenuse is always the hypotenuse. What's 40? 40 is the opposite. So I need to come up with a trig function that uses the opposite and the hypotenuse. So does that just fine. So I'm going to set up my equation. Sine of theta is going to equal the opposite, which is 40. Should have left myself more space. Over 42. Is theta all by itself? No. Sine is in the way. How do I get rid of sine? inverse sine both sides. Inverse sine both sides. That crosses out. And now you are left to find the inverse sine of 40 over 42, which I'm going to do right now. Again, you're going to definitely need a calculator for this. Make sure it's set to degrees. 40 over 42. And I get 72.2472. So I'll write all that out. 72. What did I say? 2472. Which means the missing angle is 72.2472 degrees. Okay, so again, I look at this guy right here. I need to find the missing angle. If I need to find the missing angle of a right triangle, or I'm not given the other triangle, but I'm given two sides, we're going to use trigonometry. And so I compare my sides to theta. And my sides are hypotenuse and opposite. So that requires sine, because sine deals with the opposite and the hypotenuse. So I write out sine theta equals 40 over 42. I need to find theta. So you inverse sine both sides, type it in your calculator. Bada bing. Bada bing. Ooh, now it's a little different. Now I have to find the missing side. I'm given an angle. I'm given one side. It's not a special case right triangle. I can't use Pythagorean theorem. So I look at this and I have to use trigonometry. So the angle that I care about is the only one that's given to me other than 90, 15 degrees. So let's compare x and 16 for 15 degrees. X is the hypotenuse no matter what. 16, okay, in reference to 15 degrees is the opposite side. So once again, I need the SOHCAHTOA that involves the opposite and the hypotenuse, and it's so again. Okay, oh man, we have fun. So let's set up our equation. Sine, not theta this time, because I know the angle measurement. Sine 15 is going to equal the opposite, which is 16, over the hypotenuse, which is x. Okay. Now, I don't need the inverse sine. I could just type out sine of 15 right into a calculator right now. So I'm going to do that. Sine 15, and it says 0.2588. So sine 15 is 0.2588. That's going to equal 16 over x. Now, my job is to solve for x. X is in the denominator of a fraction. So I have a number equaling a fraction. Why don't I make this a fraction and do proportions crisscross applesauce? Is this necessary? Nah, but this is just the way I like to do it. So whenever you have a proportion, you crisscross applesauce, you multiply those guys together. So that's 0.2588 times x is going to equal 16 times 1, which is 16. Is x all by itself? No. Divide both sides by 0.2588. Divide both sides by 0.2588. Cross you out, and then I'll get x. So 16 divided by 0.2588 is going to be 61.819. No units of measure to worry about, nothing like that. Black Pink one said, how you like that? But now I'm saying nothing like that. Oh, man. The last slide of this whole thing. Oh, I feel like we've been together for years, but it's only been like 2 hours. Find the missing side. Same type of problem. I'm given an angle. Here's my angle. I'm giving a side, and I need to find the missing side. I need to see what 21, 9 plus 10, and x are compared to 68. 21 compared to 68 is going to be my adjacent side. X compared to 68 degrees is going to be my opposite side. So I need the SOHCAHTOA that deals with the adjacent and the opposite, and that is TOA. So I'm going to use tangent. Let's set it up. Very similar to the last one, I'm not using theta, I'm given the angle measure. So tangent of my angle measure is tangent of 68 degrees is going to equal the opposite, which is x, over the adjacent, which is 21, 9 plus 10. Okay, you run to your calculator and you type out tangent of 68 degrees. So tangent 68, and it's going to be a terrible number, 2.475. So you become 2.475 equals x over 21. Now, I'm not going to turn this into an over 1 because all I have to do in this case is multiply both sides by 21, and that's going to make life a lot easier. So you don't need a proportion. You could, but you don't need it. That gets x all by itself. And now I need to do 21 times that number. And 21 times that number is 51.9768. So let me write that out over here nice and big. X equals 51.9768. So the last 5 videos, we dealt with a lot of solving equations. We dealt with a lot of factoring and graphing quadratics. Okay, we dealt with some geometry. We dealt with some trigonometry, some Pythagorean theorem. All of this stuff is not designed to help you master pre-calculus or AP Precalculus, but so that you walk into your AP Precalculus test or class, which is going to kick your butt. It's hard. And you feel a little bit more confident, you feel a little bit more comfortable, so that when the teacher whips out tangent and you had a geometry teacher like me who, due to a pandemic, wasn't able to get to trigonometry, you kind of know what you're doing. Okay? So thank you. If you watched all 5 of my videos, thank you for doing that. If you haven't, you should go back and check them out. Don't forget to hit that subscribe button. Being a math teacher is very illustrious, and I make a ton of money, but I could always use more. So thank you guys so much. Love you all. Good luck on AP Precalculus. You'll do fine. I believe in you, stranger. Bye.